Hello everyone and welcome to the first part of a three-part series on how to use 3D models in Particle Fleet. This of course needs a modded version of Particle Fleet that I will prepare and release shortly after this tutorial. But for now let's take a look how the 3D models work and how you can use them. In this part I will show you how to create a 3D model, how to import the model to Particle Fleet, and how to move and rescale the model. What we will do on next part you can read here, but for now let's just move on. So first, how do you create the model? You can use any 3D program that can export to the .obj of file format. This can be Blender or any other 3D program that you like, as long as it supports this file format. Next, when you are creating model, you need to make sure that the center of the model is at 0, 0, 0 in the program that you are using. Next, you need to make sure that the front of the model faces in the positive x direction. So if you are making a human, for example, the face of the human needs to be facing in the positive z direction. And finally, the up of the model, which would be like from the head up, needs to be facing in the negative z direction. So the model needs to be set like this so that you can easily work with it in Particle Fleet. Also know that different games might use different convention. So for example, in Creeper World 4, it might be that the up of the model will be the positive y direction, for example. So this is just for Particle Fleet. In other games this might be different, but this always needs to be true if you are working with 3D models. A 2D analog of this would be if you are making a 2D model, it needs to be centered in the center as well. So it shouldn't be offset like this, and it also needs to be rotated properly. The rotation also depends on the game. In Creeper World 3 and Particle Fleet, the 2D images needs to be facing to the right in the image. So if it's facing up, you will run into trouble because you will need to fix the angle when you want to rotate the image. So having the image properly rotated is always better. So in the same way, the model should be set up like this with x facing forward. I mean the forward direction of the model should be facing in the x direction, and the up of the model should be facing in the negative z. So if you've done that, let's continue. Yes. On the other hand, let me show you how you can create a model easily. You can use a program like tinkercad.com. It's online, it's free, you don't have to install everything. And I have already a model prepared here. You can just put in objects like this, resize them, rotate them. It's so easy to use that even I can use it. Let's just describe it that way. And how to make sure that these parameters are met? Well, the center is right here in the center of the grid. So just make sure that the center of the model is here and the model isn't like over there or something like that. Next, the front of the model should face the positive x direction. Now here in Tinkercad, positive x is here where it says left. So the front of the car should face in this left direction here. And the up of the model should face in the negative z direction. Now here the z direction goes upward, so the negative z goes downward. So the car should be like this. Now it is a little bit weird to make the car like this, so what I like to do is actually, oh no, misclick. To make the car like this, so I work on it, work on it, and when it's done, I just flip it upside down, and it's done. Now after you do this, you just click export, .obj, and you get a zip. And inside the zip is the .obj file, and then this obj.mtl file. Now this file needs to be in the same directory as this one. You cannot just toss it away. So I recommend just put every object in a separate direction like this, and it will work just fine. So that is how to make the model cover. Yes, just one more thing. You don't have to worry too much about the scale of the model because it can be adjusted easily. And as I already said, there is an object.mtl file generated that needs to be in the same directory. So we saw this, so let's move on. Yeah, so how do you import it? Well, you use, hang on. You use this model, load model, that first argument is absolute path to the .obj file, for example like this, and the second argument is the name of the model. So you can name it whatever you want, but each model in the core needs to have this name unique, and after you load it, it returns an ID of the loaded model, so you just save it into a variable like so. So that's pretty simple. One thing to note is that models are lost on leaving the game, so make sure to reload them in awake. So just load model like this and call this in once, call this in awake, and you are good to go. Now loading a model with the same ID from the same core will delete the old model. So if there is already a model with this name in this core, calling this will delete the old model and replace it with this one. This is good if you are changing the model while the game is running, then you can just recompile and the model will be updated. So that's good. And lastly, you can use this tray model to delete the model if you no longer use it. So that is useful as well. If you have like a projectile that shoots like a bomb that drops somewhere and then it explodes, you then remove the bomb and you are done with it. So that's that. So let's move to the last slide on how to move and rescale the model. So if you want to move it, you need to know what the coordinate system is in particular. So 0, 0, 0 is here, then x goes in this direction, y goes in this direction, and z goes actually down like this. So negative z goes up. So actually, if you go here, you can see it a little bit better because here you see the game itself. This is like a land, this is like a ship, which is on the XY plane like this. And here you can see how you can use it to set a model's position in 3D. You just set X, Y, and Z. So negative Z is up, and the model is set just like so. And if you want to rescale the model, you use it. You do it similarly. You just set the scale for X. So in this example, I just scratch it on the X coordinate a lot, not so much on the Y, and not at all on the Z coordinate. So you can rescale it on the 3 axes separately if you want to. Okay, I covered that, moving the model. Yeah, just set the position to X, Y, Z in pixel coordinates and setting the scale separate X, Y, and Z scale. Or you can set the scale to be negative and it will flip the model. However, I would not recommend this. I would recommend, if you want the model to be flipped, to actually go and flip the model itself before importing it, because you can run into some problems with rotations later if you have a flipped model like that. But it is not a really big deal. You can just flip it if you want anyway. And one last thing, center stays in the same position when scaling. So if I scale the model, the center stays the same and the rest of the model like scales around the center. And if you move the model around, you actually are moving the center of the model into the coordinate that you said that you want to move the model to. So that is important why the center of the model needs to actually be in the middle of the model. So again, as I said, you shouldn't move the model over here, because then if I set the model onto a position, it would set the position over here and the model would be completely somewhere else. So make sure the model is properly centered in your 3D modeling program. Now let's look at some examples on how to set the position and scale. Just like so, you save the variable here, and then you set the position x, y, and z. So this is actually from this example 5, 4, and -2. And you set the scale like so, just x, y, and z again. Again, the example is from this example. So I have a script here that does pretty much what uses these examples to load the model, set the scale to make the model a little bit bigger, and then all I do is listen to when V and S is pressed, and I change the X position. And this makes the model go front and back when I hit W and S. Now one last thing to note is why is the Z position -1.5? Well, as if you paid close attention, you could see that the center of the model is actually here on the bottom. So the bottom of the wheels actually go over the 0 Z coordinate. So if I set Z position to 0 here, the wheels would actually clip through the ground. So you can barely see it, but the wheels are going through the ground. So I don't want that. I want the car to be on the ground, so that's why I put -0.5 here. Because the scale is 1.5 on the Z coordinate, so if the height of the wheel is 1 from the center to the edge here, and the scale is 1.5, then after the scaling it will be 1.5. So that is why the model needs to be 0.5 on the Z coordinate, so it's 1.5 points above the ground, so that the wheels can then touch the ground exactly. Like, oh, this is badly visible. Yeah, you can see the wheels are touching the ground. So just for fun, let's say what happens if I put -100 instead. Yeah, the car just flies in the air like so. I mean 100 points above the ground, because again -Z is the up direction. So that's it for this tutorial. Next time I will talk about rotations, so that will be a little bit more fun, but this was just to cover the basics. So thanks for watching and see you next time. Bye.